I'm Paraswamy and you're watching Mr. Pakistani. Today I teach you the experiment with transformer. But first, you may see I did not upload a video about 1 month, meaning 34 days somewhere, because I am busy due to Ramadan, so that's why I could not make a video. Now I made a video continuously and I have lots of words in the video. I take lots of things in order to work right now. Now to the table. Now what I can do, this is a UPS transformer. You can see in my previous video, APC, UPS. I opened them already, so I took this transformer and then used. So I am thinking this transformer have the 4 wire in primary side and 4 wire in secondary side, meaning two winding in secondary side and is primary side. So which are two are used, white and black, which I use a multimeter to measure the resistance in order to use as an input wire. So I am thinking why this wire is not using, because what this wire do is do job it. So I thinking then I cut them in the transformer tape and I realized there are two different kind of winding. So in case of white, if I can show you clearly, there are many thin little wire. Right, try to. These are little thin wire here. This is little thin wire, which this thin wire is not a white wire and as well as black wire. Let's zoom out black wire. Underneath this tape, and this black wire to this brown wire there have other thick wire connected, and this brown to the blue have other thick winding, meaning there are, when you using a black and white, black is neutral and white goes phase. When you look phase and neutral, between phase is white and neutral is black, that case there are there's easily understand there are the neutral between black to the brown and brown to the blue and 2 more windings. So I am thinking this thin winding is not this winding. This is not a winding just like the mains winding. So it's some low voltage winding or low voltage I turn winding, because this was 2 thick wire. So that means it's I turn, and due to this wire separate them, this primary wire, because primary wire there is very low and secondary wire there is too high, so that little bit higher, so that I think they are separate together. So there are low voltage, this thick wire winding job is to produce a separate voltage which is not high voltage, just a low voltage like somewhere 15 volt somewhere, in order to turn on substitute in inverter, which I cannot use in right now because I took out this transformer for inverter and use manually. And these 15 or 12 voltage or more, somewhere this thick wire common terminal is not a neutral terminal. So neutral is common, black is common for low voltage and high voltage common. So I thinking why not test measure voltage between black to brown and brown to blue, in order to check how much voltage is getting it. First I use analog meter and it seems okay. Then I use digital meter. This digital meter works DC voltage. So there is AC voltage. In order to convert AC DC, I use a rectifier. There is a rectifier, and this time I am not using a smooth capacitor because I not know what is the correct voltage with that. But I hope this voltage is below them 13 volt, which is this meter limit, and more than 8 volt, which is my meter limit. And this time I explain a little paper and then before testing. These are static. There are basically 4 windings, 4 to 5 windings, 3 windings primary side and 2 windings secondary side. These 2 master windings, meaning thick windings, are these are 2 thick windings which I highlighted. This one is a main output, which I already used to do as a item source, and this one is separate. So those separate winding, meaning let me I show this this dark blue winding is these winding, which is between black and white wire. These and these other thin winding, meaning this bulb point like small line winding is these yellow and orange. And now left this primary side. Primary side, this P and N, meaning these two thin wires, as P contain a white and N contain black, which is a neutral, and remaining the two dark wires, meaning two thin wires, which like this blue and brown. So meaning there are brown is middle between, there are one coil between blue to brown and other coil between brown to black, and then other coil between black to the white. Black to white coil is a thin winding, which means this is a primary, and blue to black there are thin winding, which is low voltage I current winding. So that's why I little bit modify to use, because if we try to directly use, due to there are one terminal is common like a high voltage or low voltage, one terminal is common to the other, there is easily risk for getting electric shock while you get testing air these 2 points while sitting in the ground. So that's why I little bit modified, but first checked it. Multimeter seems to run properly to the rectifier. I clearly check everything is fine, so I cannot blow anything out. And this time, this experiment try very carefully, due to its work with main voltage, or it is also dangerous because we are trained with primary winding of a transformer. This is a 500 VA transformer, so it is easily kill them when if not safely handled. So that's why we think carefully that I not even try this without any experience, because this thing will I made first check this process already everything, so I know how to manage it anything. I use TDPC 3510. You can use any rectifier, but just for test I use this. And when it's plugged in, never touch anything. So I can plug the power lead, the socket is on, very carefully plugged in, and transformer is turned on. Now I arrange the meter, I arrange it. Now I plug in, carefully pick up this LED. Now I set everything. Now I set LED clip. Let's see, don't touch any bare terminal at this moment, and you can see 16.8 volt. So meaning if we measure cross a voltage between brown to blue, it may be that same voltage. It's also that same voltage, because there are maybe 50-50 ratio is, but still we can measure between brown and blue wire, and now blue and brown. 10 volts, 15 volts, let me stable it, 17 volts, meaning both the voltages are 17. So if we set a series to that, because we measure between black to blue, then we can get approximately 34 volts. But this time you might be thinking why I am measuring separately instead of one time, because my metering limit is maximum 30 volts. So I do not measure more than 30 volts. So let me explain. There are just I said there is a neutral is common, and if first I measure between neutral to the brown, mean black to brown, we get 16 volt. Then I measure brown to the blue, then I also get 16 volt. If it mind black to the blue, then we then 30 volt match, 32 volt match, which is over than voltage than this meter limit. This meter limit is 30 volts. So that's why I made separately. But you can use that way. But problem is that just you may see there are one terminal is common to the other, meaning both these brown one coil and brown to black and other coil, and black to the white also have the coil. So we need to, what we can to do, let me pencil. If you use directly, you may know neutral are connected are earth. So if you plug this transformer power supply or switch, there are switches, non-polarized switches. So meaning if you plug one way and plug other way, it will plug both the way. So if some case this black wire thumb is accidentally connected with a phase wire and this wire is connected to neutral, then you are sitting in neutral, or is common to the neutral. When you can touch this any pole, you will get electric shock, because this winding plus these three windings is connected series between power supply to the source as well as your body to the ground. That's this, it is to getting electric shock. So we need to do what we need to do in order to make a safe. We can touch this wire, thick wire in this joint, which joint is thin and thick wire joint, which is black wire, instead of black wire. So I touch only thick wire, not a thin wire, and connect with separate line which comes like there, and there is no any connection between these and these, and that's why it will not flow any primary voltage between their high voltage, which is this coil, to these and at any other coil, because we can touch or separate them, these coil to these coil, primary to secondary. Now put a winding inside, and then I touch. I first this tape off, because you can easily see what I am doing that. We said touch this wire. Very carefully touch this wire, because it will not touch any other wire or break other connections. We just touch our wire, only single this wire, and later I can little bit tip, and then I rejoin with some insulated electric wire. We do very careful. We are too closely, but due to its a short wire, so if that a little bit side, it will too short, then it's not easy to connect. Now I connect this top of this wire. Now I touch this. Now you can see I plugged in and touch this wire between these black terminals. Now I connect the one brown wire to the rectifier to meter, and other this wire to the rectifier, and then I plug this wire into there, and let's see. It will on. What is happening? This meter wire is loose, so you can see again 16 volt. That's now this 16 volt is safe in order to touch that. So that's why I am first testing with this tester, because I can not take any test risk. So that's why I test this tester. If anything is live, it will turn on. For example, if I turn a phase wire to the left of phase wire, carefully I cannot short anything. So you can see, while I touching a phase wire, the tester, it will turn on a LED, meaning this will come live. And similarly, if it is black, it will turn neutral. So meaning if I measure cross there and blue and this touch point, there is no high voltage. So it may be safe to use it. Now this point will isolate with all the primary and as well as other secondary wires. Now what we have to do is unplug and use this wire join to this point and tape it out, and all things installed, and then continue the video. Now I glue it, connect this red wire to this terminal and also glue it so it will not move back and forth and it will not come off. Now I put transformer back with this paper, which is the winding paper, which is placed top on these joints between these joints and taped between. I am used for protection of that is short tape. So now I plug these before plug. I can show you, I can tape it anything. So I can auto and then I put a tape. Now it's time to final test. Just plug it now with this electric clip. As well I touch here, you can see is that 15 volt here, and if we measure across blue wire to brown wire, we are also getting 16 volt there. So meaning if you combine this voltage with that 32 volt, and now once time we get test output, final output, and then it is working or not, then I finish the video. Oops, our glue is hot. Now I remove these all the extra wire carefully, if anything is not short. Now what we have to do, we can get the final output. This time this output is safe to touch. Also I already touched this terminal already, so I will not that extra safety here. Just randomly connect the wire by holding the meter, showing the meter. Right now there is no smoothing particle here. Six volt, 6.6 volt. Last time we did that 8 volt match is without rectification, I mean filtration. This time we did 6 voltage, meaning there are little bit drop in my power line voltage, so that's why maybe it is showing low voltage. That voltage is also fine. Now I swipe all the wires out. This time it is tested output, so it is safe to touch. Also now I swipe the other terminals. Carefully swiping the terminals because cannot short the anything, because this is a 35 amp rectifier. If accidentally with another non transferring the rectifier and short the transformer, that case it burn anything, so that's why we can carefully do. Now I measure across these terminals, positive and negative. I will meter like that, put the wire over here. It is a my machine. Why I am testing these already outputs, original outputs, while I modify it, because I testing anything is working okay, there is no damage while I made this modification. You can see another output is still coming. So all these outputs coming very well. That means now anything is not go wrong, everything is very well. Now modification is complete, and this way you can modify any transformer into the more voltage. Now if combined, let me turn off power first. So 32 voltage, that is maximum. 16 volt plus one terminal to other terminal light, red to brown, and brown to blue with that other 16 volt. So if combined somewhere 32 volt, then we combine 12 volt there. Let me once pause, I calculate it. When I calculate with that maximum 64 volt with I trans. If I connect these two series as well as these two plus all these winding fields, we get 62 voltage. So that's why we can modify 32 voltage transformer into 64 voltage transformer, and this 36 voltage transformer into 36 voltage transformer into voltage transformer. And this video is end with the next video. I should pause.